All right. We're going to be going over OpenClaw cloud architecture for companies because OpenClaw has gotten a very, very bad reputation for being insecure, right? And first, let me address the elephant in the room, right? Which is Nemo Claw. So Nemo Claw is supposed to be the answer for, let me bring this up here because this was not supposed to be part of the video, but it just came to mind. Nemo Claw, move this mic, there we go. Nemo Claw is NVIDIA's answer for enterprise grade security for basically OpenClaw. It does everything OpenClaw is supposed to do, but it's secure, which is mostly true. So Nemo Claw, secure, NVIDIA backed, does everything OpenClaw, right? That's more or less correct. The problem is that it only supports Nemotron natively. And Nemotron is NVIDIA's open source AI model. And it's good. It's a really good open source model, but it's not the frontier super intelligent models. And it runs a lot better on NVIDIA hardware. It is hardware agnostic, like they said. That is true, but it runs way better on NVIDIA hardware. And that's, I mean, naturally, it's NVIDIA. And there are some limitations, right? Because everything in its container, OpenShell as they call it, it can only do so much inside the container. And that's because they're trying to make it secure. But it limits the power of OpenClaw by putting this big shell around it. Draw a circle. There's the big shell. They call it OpenShell, right? And so this is what NVIDIA worked with Peter on creating OpenShell to make OpenClaw secure. This is really the biggest setback, the Nemotron only. You can't use ChatGPT. You can't use Claude. Yeah, you can't use any of the frontier models. You can only use Nemotron. That being said, it's still very good for basic automations like separate, single, vertical, integrated automations. It is very good for that. But what I'm about to go over here and the real power of OpenClaw and why I don't think anyone's ever going to dethrone OpenClaw in what I'm about to show you. But in order to do that, you have to implement the right architecture to keep everything secure, right? So first note, everything has to be containerized. Everything containerize, but you get it, whatever. That's probably going to mess with a lot of people. I'll fix it. There, everything containerized. And this is, so I've been using Docker with my clients, right? So let's say this is OpenClaw, right? So you have an OpenClaw agent here. OpenClaw agent. You put it in its own little workspace right here. Let's put that. And this circle here is going to be Docker. It's going to be your container. Now, there's literally an update yesterday where OpenShell is now included in OpenClaw, which is more or less the same thing, but we'll see where that lands because it hasn't been thoroughly tested yet. Now, Docker, we know Docker is secure, but OpenShell might be an answer for this in the future. But I know this works. I have implemented it myself, and it is extremely scalable and secure. Now, let's get into the automations, right? What are we looking at here? Oh, yes. So, one more thing. Inside this container, like your OpenClaw is going to be trying to do things inside your cloud, right? And it can't because there's this container wallet here. So what you have to end up doing is like making little holes for it, right? You got to give it explicit permissions to do things where it can escape and do one little thing over here in the corner, right? So that's the architecture you have to set up to keep everything secure. That way, if something does happen in this little box here, like if there's a prompt injection or something, one, it might not have write access on itself, so it can't even do anything. But if it does, and this gets compromised, it can't go anywhere outside of this container. And whatever information you might have on here should be as limited as possible so that whatever they get a hold of isn't going to be catastrophic. Okay, now let's move on to the actual automation architecture. So we basically have two standard loops, right? Loop one. So loop one is going to be your coding loop. It's going to be, you're going to need an orchestrator, which is going to be in every single AI swarm. You can have one giant one with a bunch of different automations built in, which is how I recommend to do it, or you can have a bunch of basically separate automation loops, but either way, everyone's going to have an orchestrator, right? And then you're going to have a QA manager for everything coding. Then you're going to have the actual coding agent. And you can actually have multiple coding agents here as well, depending on how big your scope is. But for most people, one coding agent is going to be enough. You probably don't need more than one, unless you're doing like massive projects. But you really only need one Q&A manager, and you really only need one orchestrator. As long as you have smart frontier models on these, you'll be fine. Which, again, is the problem. Ooh, what's going on? That's the problem with Nemo Claw, which I can't seem to get to right now. Galadriel's messing with me. But yeah, that's the issue with Nemo Claw, is that you can't put those smart frontier models to be your orchestrator and QA manager. Nemo Claw would be fine as a coding agent as long as it's in a continuous loop being with Q&A. Right? Which is the other thing. So this is actually, yeah, it's a coding loop. And I'll break it down more in detail here in a second. Now, this is going to be the second loop over here. Let's just do this. Right. Loop 2 is going to be a content loop. You still have an orchestrator. You're always going to have an orchestrator that's orchestrating everything. But here, you will always need a researcher. And this researcher can be used for multiple things. You could research things to code as well. Like you could stick this researcher you're using in this content loop. You can also make him research stuff here and have the QA manager, or I would recommend having the QA manager actually do that. You could add someone else here, like I don't know, business agent, right? So the business agent might take this research and analyze it and come up with opportunities to implement for the QA manager to implement to the coding agents. But for all content, you're definitely going to need a research agent because that's just how content works. With the coding, you can just give it to your orchestrator who hands it down the line, because that's typically how coding loops end up going, is the human tells the agents what to build. But it doesn't have to be that way. Okay, and then you're going to have a creator. This is almost always a writer, because that's what AI excels at right now, is writing. So if it's a blog, they're going to research blog topics and then pass on a blog topic to a creator. Or the creator could even pick the blog topic. There's often a human in the loop here as well, which is what a lot of people go for, so that they can pick the blog topic to hand off to the creator. Next is going to be the producer. So the producer is the one that's going to format everything, polish it up, and publish it to wherever it needs to go. And you can also have another creator here if you want. Say like, images. Might make some images for a blog post or something. So orchestrator tells the researcher what to research, or if you want it to be a true loop, you can actually The orchestrator shouldn't be here all the time, right? Same with the coding. The orchestrator is the one that like puts its hands in there and fixes stuff in the loop when it needs to happen. The loop actually happens at this level, right? Same over here. This is where the loop happens. The orchestrator kind of oversees all the loops. So this orchestrator is the same as this orchestrator over here with your agent swarm. And that's kind of the basic loops that you can plug most things into. And these are the basic loops that you need to implement into your agent automations. And then once you get these going, it's really easy to copy paste because your orchestrator will know how everything runs once you implement it with him. And you can say, hey, let's implement the same thing, but not for blog posts. Let's do TikTok slideshows, and we'll implement an automation for TikTok slideshows over here, or Instagram, etc. Or you can just do YouTube scripts. That's a very popular one, where you can do write a YouTube script, create the thumbnail, and produce it, put it all together for you. There's all kinds of opportunities here. You know, I had this whole video laid out on what I was going to cover, but I literally just like explained it all to you as I was doing the intro to the loops, honestly. Let's see what else I have here. Let me stress this real quick. Let me build out this loop one here, okay? Just do it right here. So we'll call this coding loop. This will help you guys visualize it a little better. So we're going to put your orchestrator agent on top, right? Come on, Excalibur. There we go. That'll work. And let's give him his container. A little big. Okay, so we have an orchestrator agent in its container for security. And now I want to build a coding loop, right? So what a lot of people will end up doing is be like, hey, I have my big, smart orchestrator agent running Claude Opus 4.6, super smart. Let me build another agent over here. I got a coding agent, and now my orchestrator can just tell my coding agent what to do. And now I have agentic automation. My orchestrator agent tells the coding agent to do things, and it gets built, which is where most people start if they don't just have their orchestrator agent building it on their own at all times in the beginning. I mean, that's where everyone starts. That's where I started. But if you actually want it to get quality outputs, you have to go to the coding loop that I told you about. So the first layer of defense over here, let's skip the business agent. That's because that's not necessary. We're going to create this bare bones loop that does 80% of probably what you want. Remember, I'm putting the circle on all these to stress that every single one of these is going to be containerized and only given explicit permissions to do what it needs to do and nothing else. That's how you keep these things secure. So now orchestrator agent talks to QA manager agent, right? Says, hey, I want you to let's build a Instagram clone. It's like, okay, that's kind of a big project. How are we going to build an Instagram clone? And then this QA manager is going to go over here and make this document, right? It's going to write this document. And this document is going to... Oh, that's not what I wanted. Need words. Requirements doc, right? So it's going to make this requirements doc. In this requirements doc, it's going to have steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This coding agent never sees the requirements doc. It cannot see it. Only the QA manager can see it. The orchestrator agent could see, it has permission to see it because orchestrator agent has permission to see everything the agents are doing. But it never does see it because it doesn't need to. The QA manager is the only one looking at this requirements doc. And then it will talk to the coding agent. It's like, okay, it'll take step 1 in the requirements doc, and it'll hand off step 1 to the coding agent. And the coding agent will build step 1, however long it takes. And then it will hand back step 1 back to the QA manager agent. And then the QA manager agent will take a look at it. So let's say this is the Instagram clone, right? That we told our coding agent, or not. This is the Instagram clone that the orchestrator agent told the QA manager agent, who's having the coding agent build this Instagram clone, right? So after it got step one, it started building this, but only step one so far. And now that it handed back step one to the QA manager agent, the QA manager agent goes over here and it looks at the Instagram clone. And it compares that to step one in the requirement stock. And if this passes what's required in step one here, it'll hand off step two as another command to the coding agent. But if it doesn't pass, if it makes a judgment that it doesn't fulfill everything needed in step one, it will tell it what's missing in step one, right? It'll go back here and it'll give it, step 1.1. Hey, you messed it up. You need to do this again. And the coding agent will go back there and it'll hand back step 1.1. And that's how you create this coding loop, which creates legitimate applications just by telling your orchestrator agent, make an Instagram clone. And that's the power of agentic automation. Now that I've showed you this here, I think you have an idea of the power of OpenClaw, right? Now, if this was Nemo Claw here, you'd run into problems. First of all, let's see this. Let me showcase this for you guys real quick. Things break inside of these, right? And your orchestrator agent, which is right there. Let's get these guys out of the way. Your orchestrator agent is on top of all of these automations. So these are 4 different automations here, right? And your orchestrator agent is talking to these QA managers. So it's taking in everything that the QA managers send back and forth to him. That's not what I wanted. And it's orchestrating all of these automations at all times, 24/7. Imagine not having frontier intelligence on your orchestrator agent here. That's the problem with Nemo Claw right now. When you can just put it in a Docker container, keep OpenClaw secure, and have it do all of this. Oh, and by the way, if you think about it, none of this needs access to the scary World Wide Web. Everything's so tiny now. I got so big. Boom, there we go. It's completely separated. As long as your cloud is secure, or even better, you can put that on a local machine. You wouldn't even have to containerize everything, and you could have automated coding loops. You could be creating 4 apps at once with this, or 6 or 8 or 10 of them on a local machine, just building stuff constantly with these loops, and not connect it to the World Wide Web over here. Do a big dotted line. Just don't connect it. Who cares? And then then no one can attack you. You just do it all locally. But if you want to pull in research, like if you did want to implement a research agent in here, right? Like this research agent, which is very powerful, by the way. Like one of the best use cases for OpenClaw is research. It's extremely good at that. So now the research agent is researching ideas or whatever you want in the World Wide Web over here and creating, research, intelligence, and information for everyone to pull from. But when you do that, you are now exposing your orchestrator agent to research that your research agent pulled from the World Wide Web, right? Which reminds me, by the way, never send your main orchestrator agent to go talk to the World Wide Web. Do not do that. That's how you get prompt injections. There's already prompt injections just on plain pages as it stands. So what you want to do is you want to have a research agent dedicated to research. Do not let it outside of this container. The only thing that this container can do is create these research reports, basically, which the orchestrator agent can pull from, or maybe you might even want the QA manager to pull from it directly, depending on the workload of your orchestrator agent. And then you have real outside world information to pull from when you're creating these apps that are automated, right? So once you start getting these automations built out and scaled, the power exponentially grows, as you can start to see here. But I've been going for a while. I think I'm going to call it there. But this is the power of AI agents in OpenClaw and orchestrating your agents correctly with the right architecture.